Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi for all of you. Okay, so we meet again on this video online class. Okay, but today we will learn on new chapter on for bipolar junction transistor, which is RE model and AC analysis. Okay, so we have learned on our previous class, okay, on BJT, okay, for SDC analysis. Okay, so right now we will focus on RE model, okay, how to draw the RE model and how to do the AC analysis, okay, for the BJT. Okay, now we move on the next slide. Okay, so for this video, okay, we will use BJT voltage divider bias configuration circuits, for example, to draw the RE model for IC analysis. Okay, alright, so before we going further, okay, I would like to explain the main step, okay, before we solve the problem for AC analysis. Okay, all of you know that the original circuits for the BJT, okay, we have a capacitor. Okay, in these circuits we have three capacitors, C1, C2 and C3. Okay, so the capacitor that is chosen, okay, for BJT circuit actually is a very small reactance at the frequency of the application, so that we can replace for all the capacitor, okay, by low resistance. Okay, means, okay, what the means for low resistance means we can short the circuits for capacitor. We can replace the capacitor, every capacitor, to the short circuit. Okay, this is the first step. Okay, later on I will show you how to do, no problem. Okay, the second main step is we have to remove the DC supply. Okay, as you can see in the circuit we have VCC. Okay, we have to remove the VCC, the DC supply, and then we have to replace the VCC to ground. Okay, means R1 and RC not connected to the VCC, okay, but connected to the ground. Okay, alright. Okay, let's move the next slide. Okay, once we going discuss on the AC analysis is we're going to determine, okay, several parameters. Okay, means we have to consider several parameters for AC analysis. Right, what's the parameters? Which are, we have 5. Okay, input impedance ZI, okay, and then we have input current, and then we have the third one, okay, we have output current, okay, and then the fourth one we have output voltage V out, and then the last one we have output impedance Z out. Okay, our BJT, okay, for AC represent a system. Okay, system. Later on I will explain how we define a system for BJT, especially for AC analysis. Alright, we move to the next slide. Okay, this is RE model. Okay, RE model for BJT. Okay, so our BJT that have 3 main terminal, right? We have a base, collector and emitter. For this one represent the RE model for AC analysis. Okay, AC analysis. Before we going further on the on the AC analysis, okay, to solve the problem, okay, we have to draw first the RE model for BJT circuits, okay. So this RE model, okay, suits for every BJT biasing configurations, okay, like feed bias, common emitter, common base, and so on, okay. So you have to memorize this RE model, okay, it's very important, okay. After you memorize the formula, you have to memorize the circuits, the RE model, okay. All right, let's we move on the next slide, okay. Okay, class. Okay, class. So I changed a little bit, okay, the setup. All right. Okay, first we have to redraw the original circuits, okay, for the BJT. Okay, like this one. Okay. Okay. Next, we're going to implement the two main step. Okay. First one, in order to draw the RE model. Okay, for ACE analysis. Okay, the first step is we have to replace all the capacitor, every capacitor to the short circuit. So means that, okay, sorry, means that, okay, this C1 we have to replace to the short circuit. This is to replace to short circuit. C3 replace to the short circuit. Okay, so we can redraw again. Okay, so what we have, RS, ES, then turn. So for this short circuit, okay, for the C1, okay, short circuit of C1, and then we have R2, then we have R1, okay, and then continue, okay, continue, RC, so this is our C2 replace to short circuits, okay, this is V out, positive terminal. Okay, next, okay, this part, okay, we have a two line here, RE and C3 that we have replaced to the short circuit. Okay, as you know, in the fundamental of electrical circuits, okay, the current will go through which one? To the RE or to the this short circuit. Okay, the current will go to the more or less resistant. Okay, means so this one, okay, 1 and 2. Okay, this one we have resistance RE. Okay, we have value there. Okay, but this one connect to the ground. Okay, no resistance, 0. So the current will going through to this line. Okay, 1. So we just withdraw like this. Okay, all right. Okay, next, okay, we finish on the capacitor, the first step. Okay, the next step is we have to remove the BCC and replace the BCC to ground. Okay, so let's say this one, okay, this origin circuit, we remove the BCC and we replace the BCC to ground, means this point connected to the R1 and then connected to the RC. Okay, so R1 can be connected to the ground and then RC also connected to ground, okay, like this. Okay, don't forget the terminal here. This is base, emitter, and here is collector. Okay, Okay, next is we going to simplify the circuits, okay, to become more clear. Okay, so I move to here. Okay, so now what we have, okay, this is input terminal. Yes, positive, negative. Okay, just relate. Okay, I follow this one. Okay, VS, positive, negative, and then connect to the RS. Okay, just follow. Connect to the RS. Okay, this is our RS, and then we have a R2 here. Okay, R2 here. Here we have R1 here. R1 here. Okay, R1 connect to ground. So we move R1 from the top to the bottom. Okay, move R1 here to the bottom part, and then we have BJT here. Okay, and we have it here. This is our base. Okay, this one we can connect it. We can connect this line slowly. Okay, and then the emitter directly connect to the ground. So we have emitter here directly connect to the ground. Alright, and then RC. Okay, we move to the this side. Okay, RC we can move. Okay, we can move to the ground. Okay, we move RC to the ground. Okay, like this. Okay, RC, and then this is our outright. Okay. So this is our collector. This is our VR. Okay. So all of this is gone. Okay. Okay, this is our main part. Okay, main part. Okay, our BJT. Okay. Okay, now we going to convert this circuit into RE model. Okay, we going to convert the circuit to the RE model, our RE model. Okay, first thing you have to remember what is RE model. Okay, let's we see previous slide. Okay, this is RE model. So we have what? We have a base here, and then resistor is a beta RE, and then we have a current beta IB, ground, and then we have a collector, we have a emitter. Okay, in the left side we have a base. Okay, then we have emitter directly connect to the ground. Okay, okay, I have draw this one. Okay, our RE model. Okay, class. So this is our RE model. Okay, BJT RE model. Okay, remember. Okay. Okay, so this block, okay, this block actually represent this one. Okay, this one. We have base, we have collector, and then we have emitter. This emitter. Okay. Alright. Okay, now we're going to complete our RE model. Okay, this is not complete yet because we only have a RE model. So we have to complete this RE model. Okay, that suit to our circuits. Okay, because this one we use what voltage divider, right? Okay, and then we have to complete our RE model circuits. Okay, that's suit to our circuits. Okay, if a voltage divider is voltage divider, split wires. Okay, right now we use voltage divider as example. Okay, all right. So I'm going to redraw again the our RPE model here. With the RE, what is current, with the IB. Okay, this is our base, this one our collector, emitter. Okay, alright. Okay, now try to relate to this case. Okay, so from the base, okay, in the we settle on the left side first. From the base, we this point, okay, connected to R1 and R2 and RS, okay, and also VS. So what we going to do is from this one, okay, connected to the R1 and then connected to the, okay, this is R2. Okay, from this point, okay, R2 we have RS. Alright, RS, and then this is our VS. Okay, VS represent input voltage. Alright, input voltage. Okay, next, okay, see the emitter here. Okay, see the emitter direct connect to the ground. So our RE model circuits emitter directly connect to ground. Okay, same thing. Okay, you have to relate. Okay, next one is a collector. Collector connected to the RC and V out. So we have the RC here, and then we have V out. Positive, negative. Alright. Okay. So this is our RE model. Okay, where the system? Okay, where the system? Okay, where the system like this slide? Okay, the system actually is here. Okay, here. Okay, this is system. Okay, which is you all already know that BJT actually can be amplifier. Okay, application. Okay, so amplifier is a system. Okay, that amplify from the lower voltage, okay, to the more, for example, 10 times voltage. Okay, one voltage amplify to the 10 volts. Okay, 10 times. Okay, so that the amplifier is represent a system. Okay, so we have to identify the 5 parameter. Okay, now we already know the input voltage. Okay, this is input voltage, and then okay, this is output voltage. Okay, where is the input impedance? Okay, input impedance is here. Okay, ZI. Where is the output impedance? Output impedance is here. Okay, Z out. Right. Okay. So what is formula for ZI? We can see here ZI is actually R1 parallel with R2. R1 parallel R2. And then Z out is equal to RC. Okay. Somehow in the question, for example, you need to consider internal resistor. Okay, internal resistor. You need to consider internal resistor. Okay, which is RO. Okay, where is RO located? RO is here. Okay, this is RO. Okay, so if the circuits, okay, or the question or the example, okay, require you to determine the output impedance Z out with the RO, okay, so that Z out now, Z out, okay, uh, with RO equal to RC, RC parallel RO, okay, that's all right. So I think we already complete, okay, and know how the basic step, how to draw BJT Re model, okay, for AC analysis. Next, we're going to do the analysis, okay. I want to stop our video here, okay. Then we will continue on the next video how to do the analysis, okay, not for voltage divider, okay, not for voltage divider bias circuits, and for others bias configuration circuits, okay, like feed bias, common emitter feed bias, and so on, okay. But the basic thing is you have to know the main step is what we have two main steps, okay. The first one is all the capacitor, every capacitor we have to replace to the short circuit, okay, we short the circuits, okay. And then for the DC supply we have to remove and replace with ground, okay, so that you can simplify, okay, the BJT circuits and then convert the circuit to RPE model, okay. All right, so I hope we meet again on the next video, okay. Assalamualaikum warahmatullahi wabarakatuh. Bye.